Hello, I'm Athulya Ramamoorthy. I'm a senior business intelligence and analytics consultant with Thorogood. I head up the Microsoft practice here in the UK and have over 12 years of experience with Microsoft technologies. Azure is now my chosen field of interest, and I enjoy working with customers, helping them map business needs to technology and delivering solutions that have tangible effects on their business. So today's agenda, some of you may be new to Thorogood, so we'll start with a quick introduction to us, then move on to set the stage by looking at a reference architecture for analytics in Azure, and then pick up key components one by one and discuss why they are important and where you might consider them. In the course of that, we'll also touch upon some of the recent features in each that address some really interesting business requirements. Thorogood are an independent, specialist business intelligence and analytics services firm. We've been around for more than 30 years, are headquartered in the UK and have offices in the US, Singapore, Brazil, and India. We marry analytics and technology with unwavering business focus to deliver solutions that drive businesses. We have rich experience in consumer goods, pharma, banking, and insurance, and are proud to be working with some of the largest companies in these sectors like Unilever, GSK, Lloyds, etc. We have a long-standing relationship that spans almost 2 decades with Microsoft. We've been a Microsoft Gold partner for over 15 years and are certified Gold in data analytics and cloud platform. We are a Microsoft Cloud solution provider as well, which means we host applications and services on your behalf in the cloud. If you're organized in such a way that you don't have an IT team to manage your environment, or you have IT teams but worry that they could become a bottleneck, or if you want to quickly spin off a proof of value without waiting for IT to set things up for you, being a CSP, we can help. Now moving on to Azure, here's a sample of the available services. Does this view look overwhelming? Part of what makes most cloud offerings daunting is the vast choice available, and the choice is only increasing. There's never a hard and fast rule, but what we have seen help is never looking at technologies on their own, but in the context of the business challenge that they are meant to address. So this is an example architecture for delivering analytics on the cloud. You're seeing a blank screen now. So first comes the data sources. These could be, as you can see, from ERP systems, databases, or flat files. It could also include structured or unstructured or semi-structured data like audio, web APIs, Twitter feeds, etc. Data is pulled from these data sources into a storage layer like the data lake. Here, data is cleansed and transformed using tools like Azure Databricks. This cleansed data can then be stored and modeled in the semantic layer using tools like the Azure SQL Datawarehouse. All through this, you will notice extraction and orchestration is facilitated using a tool like the Azure Data Factory. Finally, when the data is ready, it can be analyzed using software like Power BI or shared with someone else using the Azure Data Share if you feel so. Almost everything you see here is a PaaS offering, that is, it's a platform as a service, which means you don't worry about server configurations and updates. All of that is abstracted, and you just spin up a service with a few button clicks or scripts and get started with what you want to do. This is also arguably cloud's biggest benefit. Time to value is drastically reduced by letting you focus on what's important to drive the business. Of these, so the first aspect we're going to look at is data movement. Azure Data Factory is your data orchestration tool in Azure. It is for data movement, plain and simple, and it does that very fast and very effectively. It can connect to a multitude of sources, that was about more than 80 at last count, and can bring data into Azure where you can then modify it based on your needs. It is serverless and it is integrated with Azure AD as well for security. ADF is also integrated with SQL Server Integration Services, which is a major factor in its favor, and we'll look at that in the following slides. And then there's data flows. We'll look at this in some more detail too, but at a high level, it brings to ADF transformation capabilities which previously were not ADF's strong suite. So what is ADF's strength and where would you consider it? For many organizations, except in the case of cloud-first applications, the bulk of the data is often on-prem. Landing on-prem data into the cloud is a first step towards leveraging the rest of the Azure offering, and ADF makes this step really easy. The support of almost all types of data sources, including the recent addition of SAP BW, Open Hub, and SAP Table, makes it very often the default option to land data into Azure. Now, simple transformations. If you have the need to copy something from A to B, then you probably don't need to look further than ADF. ADF's strength is data orchestration, as we've already touched upon. It provides the pipelines to move the data through a process, simple mechanisms to shape or modify the data, and then lets you leverage SQL procedures or Azure services like Databricks or Hadoop clusters within an ADF pipeline to do the more complex tasks. Do you have a lot of existing SSIS footprint? For the cloud, the SSIS was the choice for data movement and transformation in the on-prem Microsoft BI landscape. It is in fact unmatched in its capability to facilitate some rather complex transformations using a simple graphical interface. Couple that with the fact that there is a ton of SSIS knowledge within organizations, there's a very good case to be made for continuing to make the most of the investment even as companies make the move to the cloud. If you have a well-designed SSIS package, if you have multiple well-designed SSIS packages that do the job, and you are in no hurry to replace them with a cloud-first service, ADF can help you maximize your ROI. ADF lets you reuse your existing SSIS packages with very little additional effort. We won't go into a lot of detail here, but SSIS integration runtime is what makes that possible. Here are a few other very specific scenarios where it's worth considering ADF if you use SQL Data Warehouse. Of all the options to land data into the SQL Data Warehouse, ADF comes high up there in terms of its capability for high performance. The next is if you wanted to call on-demand services like HD Insight to do the number crunching for you, or if you have a lot of, say, machine learning models, ADF works with them in different ways, all of which may be useful depending on how you use your models. ADF can invoke an Azure ML productionized model to make predictions on your batch data. You can use Azure ML service pipelines as a step in your ADF pipelines. Or if you are going to look at operationalizing a machine learning model, ADF has options for that as well. So until now, Azure Data Factory lacked commendable functionality to transform data, but that is no longer the case. Mapping data flows is a cloud-native functionality which adds a graphical data transformation tool to Azure Data Factory. So as you can see on the screen, you can do things like conditional splits, joins, unions, etc. with this. Or if you wanted to do agile data preparation or exploration, a wrangling data flow may be of interest. It's something that brings to you the power of the Power Query online mashup editor. The next part of the architecture we look at is data processing. And for that, we're going to look at Databricks. Databricks builds on the open source Spark platform. It takes all the advantages of the Spark platform and extends it to make it easier to set up and use and make it ready for the enterprise. Spark requires a cluster of computers to be set up, and Databricks automates this process, so it's as simple as choosing the number of computers and their size, and then Databricks handles the rest for you. On top of that, Databricks will handle auto-scaling, so you only pay for the compute power that you actually use. And that can mean really big savings if you're running occasional analyses that need lots of compute power, but for short periods of time. Databricks also has enterprise-level security built in, and a number of other enterprise features for collaboration and integration with a number of front-end BI tools. So where would you consider Databricks? Is SQL Data Warehouse a core part of your architecture? Similar to Azure Data Factory, Databricks uses specialized data warehouse connectors to transfer large volumes to and from the data warehouse. Both the Databricks cluster and the SQL Data Warehouse instance acts as a common blob storage for the data exchange, and Spark jobs are used to the Databricks end and Polybase at the SQL Data Warehouse end to make performance as optimized as possible. The SQL Data Warehouse connector is more suited to ETL than to interactive queries, because each query execution can extract large amounts of data to the blob storage. So if you plan to perform several queries against the same SQL DW table, you should look at saving the extracted data in a format such as Parquet. Dynamic scaling. Now that depending on the workload, Databricks can auto-scale, that is increase the number of worker nodes. Of course, you have to define the max number when you set it up, but then Databricks takes care of utilizing only as much resource as is required to complete the task at hand. Databricks can also auto-terminate, so your cluster will shut down after a specified amount of time once the jobs have completed. If you have ADF pipelines and you want to do some processing in parallel, you can look at leveraging Databricks within ADF to run those parallel tasks with all of your code within the Databricks notebooks. Streaming ETL, now that's a very interesting use case. If you seek continuous answers from your data without having to wait for the batch processes to complete, then Databricks streaming ETL is something you should definitely look into. If, for example, you were to be notified of account tampering or a weather monitoring system where to flag high alert situations, you want both to happen as and when the data flows through. And structured streaming on Databricks leverages powerful Spark SQL APIs to provide a seamless query interface, and it also optimizes the execution engine to enable low latency, continually updated answers. In 2019, a new feature called Managed Delta Lake was introduced. Delta Lake is an engine built on top of Apache Spark that adds a new storage layer to it. And this functionality enables data scientists to implement near real-time analytics use cases like augmenting Twitter feeds, etc., without having to implicate complex streaming logic. There's good reason why Databricks shows up in most cloud architectures. Most analytics applications require advanced transformations and huge number crunching, and these are without doubt Databricks' strength. Databricks also lets you code in any language, which takes away a huge bottleneck in terms of availability of skill sets as well. You can leverage knowledge of R, Python, Scala, SQL to quickly get started. And if you were lucky enough to have skills in all of these, then Databricks allows you to leverage different languages for different sections of your notebooks to play to the strengths of each. Think of a notebook as a collection of code that sits independently to the Databricks cluster. Is machine learning, is it important part of your application? In which case, Databricks' offer for machine learning applications will be of use to you. It offers a unified analytics platform meant to unify data science, data engineering, and business. With Managed MLflow, Databricks offers a hosted version of MLflow, which is an open source platform for optimized auto-scaling Apache Spark-based environment. And along with that, it offers a host of other features for machine learning on the cloud. Moving on to the next layer, we've got Azure SQL Data Warehouse. Azure SQL Data Warehouse, or Azure SQL DW, is a fully managed cloud warehouse and a follow-on from Microsoft's older, if you can remember it, parallel data warehouse. It offers lightning-fast query performance and incredible flexibility via Polybase. It boasts of industry-leading security and fits right in with the other services on Azure to build a brilliant analytics platform. It can address many use cases. It can be used as a modern data warehouse, real-time analytics platform, and it's also an option for migrating from an on-prem huge data warehouse. The close integration with Databricks is a huge advantage. Between Databricks and data warehouse, they're geared for optimal performance on the cloud. So is SQL Data Warehouse for you? It is a massively parallel processing system. It really is meant for big data. So unless you have data volumes approaching 1 terabyte or so, you may not need SQL Data Warehouse. Behind the scenes, SQL DW really decouples storage from compute and control. It is really 30 SQL databases bolted together for storage. There are considerations around how the data should be sharded across a distributed platform, and these are design decisions that have to be taken by your solution architects. Data Warehouse is completely elastic, so you can scale compute up and down with a slider, and you can pay for whatever you use, essentially. So if your analytics processing goes through peaks and troughs, then the elastic compute will give you significant cost benefits. Now, this is something that may resonate with many of you. Often you want to innovate on current data, and there are many bottlenecks you come up against. Processes are rigid, adding new capability or enhancements has lead times. In the traditional world, it could involve buying hardware, and so slowly you end up with a backlog of projects that could potentially help your business a huge deal, but are just piling up for a lack of flexible, easy access to data that also combines massive analytical capability. And here is where Data Warehouse can help. It can help you leverage data that lies in various places, and even without necessarily spending a lot of time and effort cleaning or structuring it, Data Warehouse lets you derive value from it really quickly. SQL DW is not a transactional system. It is meant for OLAP use cases, aggregated data across massive volumes. Often we see Azure Analysis Services as a natural fit for many use cases in these scenarios. So you use SQL Data Warehouse to do the heavy lifting, and then you use Analysis Services in the front to do the complex analysis on the results. Distributed parallel processing use. If you have processing requirements that could benefit from being broken into chunks and run in parallel, then the MPP architecture of Data Warehouse would be very useful. I must also say that if your processing doesn't lend itself to being distributed effectively, or if the data sizes are too small, then you actually risk a significant performance penalty because of the overhead incurred to distribute and consolidate across your nodes. So that's something you really want to look into quite carefully before you adopt SQL Data Warehouse. Do you also have a lot of data in different places that you haven't quite figured out exactly how to process and land in a clean data warehouse structure? For such scenario, SQL Data Warehouse uses data virtualization to bridge data across many sources without replication. So with this feature, you can keep data in its original location and create external tables to explore data from those sources. This is a super quick way of beginning to look at data that may or may not be useful and assess what you want to do with them and how. Now, I'm not suggesting here that you hand over less than perfect data to all your users, but there are data scientists and power users who may know what to do with it and how to make sense of it. So you should give it to them and let them derive value out of it. We'll also take a quick look at some of the other interesting additions to the service. There is reserved capacity pricing for SQL Data Warehouse now. It essentially lets you reserve compute power for the future. You can do it, I think, for up to about 3 years, and the savings that comes with it can be significant. There's a private link that allows you to connect to various PaaS services in Azure via a private endpoint. This is a huge deal if security on the cloud was one of your concerns that limited adoption of certain services, including SQL Data Warehouse. You can enable cross-premises access to private endpoint, and you can then disable all access via the public endpoint and not use the IPv firewall at all to allow any IP access. You also have materialized views. It helps with performance. It essentially parses data from the view query and then gets updated based on changes in the base table. So this way, complex queries perform better without having to hit the base tables over and over each time. Then there's result set caching. This is also very interesting, and it's quite aptly named, really, because Data Warehouse essentially caches results from repeated queries so it performs better. Equally importantly, it saves compute cycles because it doesn't need to be computed over and over. It also avoids concurrency slot usage, which means you could potentially serve more users than are supported by the concurrency limits. You can also hide and mask sensitive data now, which is an added security measure, and you've got multiple options to choose between them. Then there is data discovery and classification, which I think is in preview currently. It offers several services for discovering and classifying sensitive data by using sensitivity labels and information type in the database and so on. So it's just Microsoft taking security really seriously and putting in features that with added visibility and stressing on handling sensitive information. Until now, looked at SQL Data Warehouse and the rest of the stack, and now we'll move on to Power BI, which is Microsoft's reporting analytics tool to enable quick insights and detailed analysis alike. When you have an end-to-end architecture for analytics, and we've discussed reasons and features that make some of these services perfectly suited for that, you also want a front end that can integrate with them perfectly. Power BI is everywhere now, so I won't really spend time introducing it too much, but we'll touch upon some interesting new updates to it. But if you did want to know more about Power BI or how it can help you, please get in touch. Power BI has come leaps and bounds from when its first version was rolled out. You may be aware that there are monthly updates being rolled out now, so it's a hugely interesting tool and it's constantly evolving as well. A couple of useful features from the latest update that I picked out. So there's Power BI now allows you to format how a measure shows up in a visualization, which means you can show the measure differently depending on where you're showing it in your report or at what level you're showing it. It also allows you to use conditional formatting to decide visualization details like borders, data labels, etc. So, for example, if you want to now display negative numbers with a red border, for example, you can do that. Power Apps, another important tool in the Power Platform, integrates with Power BI now to facilitate a lot of features that aren't native to Power BI but can be brought into the same sort of Power BI window quite seamlessly. Power Apps for Power BI has always been there, but it's now native and it's certified. A very common use case of Power Apps that I've seen is to support comments within Power BI that are tied to the data points as well. In terms of data sourcing and prep, if you've used Power BI before, you would have noticed that Power Query has slowly been updated with a lot of options to help you identify columns with errors, etc. And now there's more detailed data profiling options and the ability to copy that to clipboard and then into any application you choose to further analyze the discrepancy in your data. So that can be really useful, especially if you're exploring your data and you want to get to the bottom of something. If you were connecting to multidimensional models, which still exist, there's something new there as well. Improvements have gone in to reduce the chattiness between Power BI and analysis services, and also to provide better query performance and measured execution. For those that use Power BI in direct query mode, and direct query is where Power BI doesn't bring in the data, it runs queries directly against the source. They've now introduced another feature to further improve performance in this area, I won't go into the technical detail here, but please do get in touch. This is a very interesting field, and a lot of large enterprises have a lot of use for this feature as well. Power BI, what is in the roadmap? I thought I'd just highlight that Microsoft have put together a list of planned features at this link, and they very usefully tick off those that have been rolled out. So this is a really good feature because it gives you visibility of things that may be coming and may be important to you. So if you're keen to see what's in the pipeline, please take a look at that link. So that concludes our webcast today. If you think of something later, please feel free to get in touch with me on my email ID or connect with me on LinkedIn. On that note, thank you and have a great day ahead.